Hi, geometry students. Okay, now I happen to be eating and talking, but since you can't see me, I think that's okay. So, this last section in chapter 8 is on something totally new that you've never seen before. Okay? And it is an extension of trigonometry. It's where we can make use of trigonometry. And it's known as vectors. So I'm going to go right into it. And you guys, I believe you can understand this information by watching these videos. I believe this. It's just you have to put in the actual effort of watching it and letting your brain learn it and not be just talking to people during the video. You can do this, people. Okay? Focus. All right, vectors. Vectors, what the heck are they? Okay? They are any quantity with two things. One with magnitude, which is also known as the size, and direction. Okay, we'll get to some examples, so just calm down. Vectors can be written in two ways. You'll see them written one way, for example, like this, KW with a, looks like a type of arrow above it, where K is the initial point and W is known as the terminal point. And the magnitude, the size, represents the distance from K to W. Okay, and the second way you'll see it is in the coordinate plane, and it'll look like an ordered pair, but you'll know it's a vector if it has these types of things on it instead of parentheses. Okay? And the ordered pairs in the coordinate plane are always originating from the origin. So I'm going to just go ahead and hop into some of these. I'm just going to start practicing them right away with you, and hope that you follow me here. So I'm going to go to page 529, and you're going to work right with me unless I tell you to pause the video. So on number 10, so you're looking at number 10, I'm going to draw it out. You can pause the video to get a book, get yourself ready, and then start it with me. Okay? Don't try this alone yet. You'll be too scared. Alright, so I'm just drawing the picture. I'm drawing it out in my notes of what they told me, what they showed me. I see an arrow, and it says describe each vector as an ordered pair around the coordinates to the nearest tenth. It tells me this vector has a what of 900. That 900 represents something. The 900 is the magnitude. Okay, that's the magnitude of this vector. That's the size of this vector. And then the 48 degrees is telling me the direction. And if I were to be more specific, I'd say, and it didn't ask for this, but I'm going to go ahead and do it. The magnitude of this vector is 900. The direction of this vector is 48 degrees, and then I have to give, some sort of direction. Something of something. So it's going upwards, okay, from this direction, and this direction is east. So I'm going to say, not east, I'm going to say it's going north. So this arrow is going north of east. North of east. Because if I switch that around and say it's east of north, well, that means I'm starting at north and it's headed east, which means it's going this way, which is not. It's east. No, not east. It is north of what? east. So I start at the east and I go north of it, 48 degrees. If you're not understanding that part, just hold your horses. I'll do some more. We also need to write this as a ordered pair. So remembering that we're using those arrow type heads for the ordered pair, we need to know the x and the y coordinates. So how can we get those? Well, we'd make use of trigonometry. Because if you actually look, we have a right triangle that's formed. See that? You can highlight with another color too, right in there. And I'm going to go ahead and write in that this value is going to be my x coordinate, and then this value is going to be my y coordinate. So I'm going to have to make use of trigonometry twice. So I'm going to end up using, to solve for x, I'm going to end up using the not sine, but cosine of 48 equals the adjacent over the hypotenuse. And I would go ahead and solve that for x. And then to solve for y, I already would then have the x, so I could make use of the Pythagorean theorem, but x will be not a nice number. So I would just go ahead and use trig again. So I would not use cosine because now this is the opposite side. So I would use the sine of 48 equals y over 900. And I would solve both of those for x and y. And I should end up with my x value, and it says to round to the nearest tenth, x value at 602.2, and my y value at 668.8. Okay, we're going to try another one together. Okay, let's go ahead and look at number 11. It does just ask for an ordered pair to describe the vector. But I want you to practice with all of it. So I want to know the magnitude of this vector. I want to know the direction. And I want to know the ordered pair. Okay? So in number 11, looking like this, you're drawing it, you're staying involved in the problem. If you are having a discussion, you're pausing the video and you are asking the questions that you need, okay, with each other. If you're still unsure at this point, that's okay. This is just the second example, okay? With the given information, I already have the magnitude in the problem, so I can figure that out. What do you think it is? Okay, it is the size of the vector, and it's right there. It's 51. So I'm going to go ahead and write in magnitude is 51. Direction. I pretty much have that also. It tells me 55 degrees, and then I need some sort of north, south, east, west. So this is 55 degrees, blah of blah. Blah of blah. So to get to this arrow, where would I start from? I'm going to start from this direction, which is west. And then it was this way from there, which is north. So I'm going to say the direction is 55 degrees north of where? Of west. So I'd start at west and go north 55 degrees. So there's my direction. And now I need the ordered pair. So now I'm at make my right triangle. I'm highlighting so you can see which right triangle I'm using. I'm going to label my x and y coordinates. This is my x, this is my y. And I'm going to use that trigonometry twice. Sine of 55 equals opposite over hypotenuse. And then I have cosine of 55 equals adjacent over hypotenuse. And when I solve that, I should end up, you can pause the video and try to get those numbers and see if you get the right numbers, because they are negative 29.3 rounded to the 10th and 41.8. Alright, I'm going to go ahead and say try number 12 on your own. Pause the video. And then I'm going to pause also, and I'm just going to write out what the answers are. Okay? And you can come get me in algebra if you need me to explain number 12. Okay? All right, so go ahead and pause and try it. Okay, 3 things I wanted: magnitude, direction, and the ordered pair to describe this vector. Magnitude is 75, direction is 30 degrees, what of what? So I'm going to start here, which is south, and I'm going this way, which would be east. So I'm going to say 30 degrees east of my initial starting point, south. And then the ordered pair for number 12 to the nearest tenth is going to be 37.5, comma, negative 65.0. Okay, onward. We are going to look at the next chunk, 13 through 15. In 13 through 15, those are simpler, just asking for the compass directions to practice that. So go ahead and practice 13 through 15, just telling me the direction of that vector. So 13, if you need my help, I'll do this one with you. 13 is going to be, it says 15 degrees here. So right away, I see this. It's coming from there because the 15 is adjacent to that line. So that is where I'm going to start from, which is west. So that's going to be my last part. And then it is going south. So I'm going to say it is 15 degrees south of where? Of west. 15 degrees south of this westward direction. Okay, number 14 and 15. Practice on your own. Pause the video because I'm just going to write out the answers for you and move on. Okay, number 14 is 20 degrees west of south. Number 15 is 40 degrees east of south. Okay, then I'm going to move on with you to problem number 22. So go ahead and read number 22. Pause video, read it yourself, try and draw the picture, and then start the video and we'll try and figure this out together. Okay? Because I'm going to start. Alright, so the picture I would draw on my coordinate plane would be 73 miles west. So I'm going to go this way. 73 miles. I'm going to label that. There's my first vector. And 64 miles south. 64 miles south. So I know that's going to be 90 degrees. And then what are the magnitude and direction of its flight vector? So its flight vector is going to be this right here. Okay? Its flight vector. So I need to know the magnitude of this and the direction of this. Let's start with magnitude. I need to know the size of this vector. Well, I have a right triangle, and I already have 2 sides given. So what could I make use of? I could actually use the Pythagorean theorem. So I'm going to go ahead and do 64 squared plus 73 squared equals question mark squared. And then I'm going to square root it to get a magnitude of, for number 22, we need to do some calculating. I don't know that off the top of my head. 64 squared plus 73 squared. And then I'm going to square root that. There it is. So that is, it does not tell me how to round, so I'm just going to go to the nearest mile. And that is 97 miles. So I'm going to say, boom, got that. I was able to say the magnitude is 97 miles. And it also wants to know the direction. So the direction, I need a degree. And I need it from the origin, so I need this angle right here. Okay, and that's a theta symbol. That's the variable we end up using to describe an unknown angle. and I